So earlier this week we talked about solving quadratics by factoring. So if we were looking at this problem, we're saying, okay, we've got x and x to get my x squared, minus 5 plus 6. So I need two numbers that add to be negative 5 and multiply to be positive 6. I'm going with negative 2 and negative 3, setting equal to 0. So then I'm setting each piece equal to 0. So x minus 2 equals 0. Add 2 to both sides. And then we've got x minus 3 equal to 0. So x is 3. So the next thing that we have to look at is, what do you do if the quadratic can't be solved algebraically or factored? So this is where we bring in the good old quadratic formula. If you remember, the quadratic formula is something we applied when we have ax squared plus bx plus c. So a is always the number in front of the x squared, b is the number in front of the x value, and c is the constant. And it always has to be equal to 0, and you really want to keep that a positive if you can. So the quadratic formula says that x is going to equal the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So when we're looking at a problem like this, the first thing that we want to do is identify a, b, and c. So in this problem, there is no number in front of that x squared, which means that a is 1. The number in front of our x is negative 5, so b is negative 5. And our constant then is our plus 6. So then the next thing that we're going to do is just substitute those values into the quadratic formula. So we've got x equals the opposite of b, b is negative 5, so the opposite of negative 5 is positive 5, plus or minus negative 5 squared minus the quantity 4 times 1 times 6. It's important to put that in the quantity because sometimes you're going to end up with negative numbers, minusing a negative. So just keep that in a quantity all over 2 times a, or 1 in this case. So then from there, we just simplify it out. So in our next step, we end up with x is equal to 5 plus or minus 25 minus 24 all over 2. So then that gives us 5 plus or minus the square root of 1 all over 2. Then we look at this here. If it's a perfect square, then we have one more step. If it's not a perfect square, we can leave our answer just as it is if it's simplified. But if it's a perfect square, then we have to go one step farther and separate them into 2. And what I mean by that is we have to look at 5 plus or minus 1 over 2, because the square root of 1 is 1. So then that means 5 plus 1 over 2 and 5 minus 1 over 2. So we've got here 6 over 2, so x is 3. Then we've got 5 minus 1, 4 over 2, or x is 2. And that would be our final answer for that problem. So in our next problem, we've got x squared plus 2 equals negative 3x. So the very first thing that we have to do is get this negative 3x over to the other side. So we move that by adding 3x to both sides. So we end up with x squared plus 3x plus 2 equals 0. So then again, what we want to do next is identify our a, b, and c. So a is going to equal 1 in this case because there's no number in front of the x squared. B is going to be 3, and c is going to be 2. So then we put those into the quadratic formula. So x is equaling the opposite of b, so negative 3, plus or minus the square root of b squared minus 4 times a times c, so 4 times 1 times 2, all over 2 times a, or in this case 2 times 1. So again, this is a 3. So again, the next thing that we want to do is simplify that out. So we end up with x equals negative 3 plus or minus 9 minus 8 all over 2. So x equals negative 3 plus or minus the square root of 1 over 2. So again, we look at here and we simplify that radical. It's a perfect square, so x equals negative 3 plus or minus 1 all over 2, which means negative 3 plus 1 over 2 and negative 3 minus 1 over 2. Negative 3 plus 1 is negative 2, divided by 2 is negative 1. Or negative 3 minus 1 is negative 4 over 2, x equals negative 2. So then I want to show you one last problem where the radical here isn't a perfect square. So we identify a equals 2, b equals 4, c equals negative 7. So we're going to substitute and simplify. So what we're looking at here is x equals the opposite of b, so negative 4 plus or minus 4 squared minus 4 times 2 times negative 7 all over 2 times 2. And that gives us negative 4 plus or minus 16 minus negative 56. 4 times 2 is 8 times negative 7 is negative 56. So this negative here will make it plus a positive. So we end up with negative 4 plus or minus the square root of 72 all over 4. And so here's where we want to take a look. 72 is not a perfect square, but it can be simplified. If we simplify 72, we've got 2 times 36, which is 6 times 6, and we could stop right there because we have our pairs. So this is equal to negative 4 plus or minus 6 radical 2 all over 4. Because it's not a perfect square, we can leave our answer in the plus or minus form. We just have to make sure that we look at the coefficients. 4, 6, and 4 all have a common factor of 2. So we need to simplify so that our final answer is x equals 2 plus or minus 3 radical 2 over 2. 2, 3, and 2 don't all have a common factor. So this is our final answer. All right, and off you go.